if we can think what's going on with these trig functions, of course x is approaching pi over 2 from the left. I think a quick graph of the secant function would be helpful to see what's going on here. I never have the graph of the secant function in my mind, but I usually have the graph of the cosine function in my mind, and that's reciprocal to secant. So a quick sketch of the cosine function, close to pi over 2. Cosine starts at 1, and then goes to 0, and then goes to -1, and then back to 0, and then back to positive 1, where these, of course, are pi over 2, pi, 3 pi over 2, and 2 pi. So I can put the pi right there. So cosine does, I should make it dotted or dashed or something like that. Cosine does something like that. Now wherever cosine is 0, it's reciprocal. Secant has a what? Vertical asymptote. So secant has vertical asymptotes there. What's the reciprocal of 1? 1. So when cosine is 1, secant is 1. Now as cosine heads down towards 0, reciprocals of numbers that are headed towards 0 from above are heading toward positive infinity. So that's what secant's doing. And as cosine, let's see, as x comes up here toward pi over 2, through these negative values, tiny, tiny negative values for cosine. I forgot to ask, what's the reciprocal of -1? -1, yeah, so secant of pi is -1. Secant's doing this. There we go. So then you can draw the rest of the secant graph if you want it. We don't need the rest of the secant graph, but that's kind of what's going on. So as x approaches pi over 2 from the left, so we're doing this, pi over 2, oh, wait, that's the right. That's the right. And I erased the x-axis and no telling what else in the process. Put it back. From the left, it's doing this. Secant is going where? Positive infinity. So secant x is going to positive infinity. X is going where? Well, as x goes to pi over 2, where does x go? Pi over 2, yeah. Pi over 2. So x is going to pi over 2. Secant's going to positive infinity. So we can apply this one right here with L positive, and the other one going to positive infinity. So the product is going to be positive infinity. There we go. From the other direction, there we go, I should have just done this one. From the right, x is going to pi over 2. Secant is going to negative infinity, down like this. And so we have positive numbers times arbitrarily large negative numbers. And that product is going to be larger and larger negative numbers, so negative infinity. And the c part, it illustrates, I think, C part is intended to illustrate this first one here, but it seems fairly obvious. I think it is fairly obvious once we see what cosecant is doing. Cosecant and sine are reciprocals of each other, yes? No? So sine, as x goes to 0, sine of 0 is what?
0.
Sine of 0 is 0. Yeah? So that sine is going to 0. Cosecant, now if x is a little bit more than 0, just a quick peek at the sine function. If x is a little more than 0, is sine, over here, right here, is sine positive or negative? It's positive, yeah. So cosecant is positive, so evidently cosecant is going up like that. That's what cosecant's doing as x approaches 0. So let's get rid of the sign. So positive infinity. So cosecant is going to positive infinity, sine is going to 0, and their sum very easily is going to positive infinity. There's just no worry at all if there could possibly be anything else.